Okay, so we continue our discussion in section C, okay, part 3, which is also regarding chapter 5, okay, group 4, 14 elements. Okay, so our first question, question 12. So this will be the question 13 in your exercise. So it's a question in 2019. So silicon and semiconductor material used for the production of silicon chip. Which is silicon? Why a silicon a semiconductor while diamond is not? Explain your answer in terms of energy band. This is also the similar question we actually already discussed at the years of 2012 and 2019 repeat for term 2. So according to our discussion, both of the question actually not ask you to explain the conductivity based on the energy band. So the main difference for this question is in 2019, so the question requests you to explain the conductivity in terms of the band energy. So as per our discussion, example of the marking scheme for 2012, comparison of conductivity between the titanium and germanium. According to the scheme is we can actually explain in terms of the energy band and also the concept of presence or absence of delocalized electron. If we compare the Laporan Peperiksaan 2012, right? So and in 2013 repeat for Sem 2, we don't have any reference for the Laporan Peperiksaan. According to the scheme, given that the discussion is only involve the concept of delocalized electron. However, I advise that both of the concept which is regarding the delocalized electron and the energy band is better include in your answer, right? So in this question, we can focus on the explanation for the energy band. Actually, the delocalized concept is related to the energy band here. We discussed about the conductivity since we see the words of the energy band. This question not ask you to compare conductivity, but in terms of energy band, we discuss the conductivity of the silicon and the diamond. Okay, so here we have to do the comparison between two elements, not the trend of all the elements group in group 14. Okay, so as we already know that the carbon have 3 electrode, which is diamond, so graphite and fluorine. Okay, so we again have a revision back to our section 4.5, okay, regarding density and conductivity. So we can see that the conductivity increased down in the group, reflecting that increasing metallic character from carbon to lead. So will become more conductivity. Okay, so this is because the structure of element changes from the giant covalent to the metallic structure. So the metallic structure here will be the tin and the lead. So hence the electrical conductivity increases. If we see, okay, I discussed already, okay, because of first three, they have the giant covalent structure, so they are considered less conductive, right, compared to the tin and lead. Okay, so if we discuss the diamond, there is a non-metal, and the gap energy between the valence band and the conduction band is large, so that the electron cannot be jumped to the conductor, to the conduction from the valence band. Okay, so this one will be have to discuss in your answer okay, because the question asks about the diamond and asks you to discuss in terms of the energy band. And the next will be the silicon and the germanium. They are semi-metal or metalloid. It has a electrical conductivity between electrical conductor and insulator. So the energy gap between valence band and the conduction band is small. So electron can jump from conduction band to valence band. Okay, so we have to discuss these two in our answer. Since the question asking you to compare the conductivity in terms of energy band between the silicon and the diamond. So thin and lead not in our discussion. Okay, see the question asked about the silicon, which is a semi-metal, and the diamond here will be the non-metal. So the discussion in terms of energy band will be between the energy gap for diamond and the energy gap for the silicon. Okay, so we'll discuss carbon and the silicon only. Let us look at what is the importance point here. Okay, so firstly, as I mentioned, we need to compare both the silicon, diamond. Okay, so the diamond considered as non-metal. Okay, so that means the delocalized electron is absent, and you can discuss also but here we mainly have to discuss in the energy band. Okay. Okay, so the first advisable answer here will be silicon is a metalloid, diamond is non-metal. So this is the first comparison. So you will get first 2 mark here. Okay, and then the second, we discuss in terms of energy band for the here mentions small energy gap, right? So it will be for the silicon. So there is a small energy gap between conduction band and valence band in silicon. It has electrical conductivities between electrical conductor and insulator. Electron can jump from valence band to conduction band. Okay, so this was his electron. Okay, and we discussed about the valence band and conduction band in the diamond, which is have a very big energy gap. So the electron unable to jump from the valence band to the conduction band. So you can compare the answer here with the Laporan Peperiksaan 2019. So the firstly, majority of the candidates were unable to relate semiconductor properties of the silicon and the diamond in terms of energy band. So that means the students maybe discuss regarding the delocalized electron here. Okay, so here you can see there is no any mark is given or no any discussion regarding the delocalized electron in the scheme here. Okay, because the scheme is due based on the Laporan Peperiksaan. So that means the first part here mentioned candidate majority unable to relate in terms of the energy band. So that means if the question already give you band, so that means you have to discuss in this term. Okay, besides this, the answer, the mark will be not given. Okay, so this one you have to take note. Okay, what is actually the question request? Second, most candidate write about the difference in the structure, but actually silicon and the diamond, they have the same structure, which is the giant covalent structure, right? So this is a common mistake made by the previous Stpm candidate. So the candidate were expected to explain the electrical conductivity of the silicon and diamond using the energy band. So as mentioned just now, the common mistake made by the student is actually both the silicon and the diamond is a giant covalent structure, and the explanation in your answer must be involved energy band only. Okay, and we have to do comparison, okay, between silicon and diamond. So this is already settled in the first answer here, reference answer here, where the silicon is a metalloid and the diamond is a non-metal. Okay, clear? We have to explain the differences between the carbon dioxide and silicon dioxide in terms of their structure and physical properties. Okay, so when we have to discuss about the structure and physical properties between the carbon and silicon, we can refer again this table. So this table, you can see again, we just compare two compounds. It's not all the compound in the table here. So for the structure, you can see there will be simple covalent molecule for the carbon dioxide, while giant covalent structure will be for the silicon dioxide here. So the point you have to write at least 8. Okay, since the mark for this question is 8. Okay, the second, you have to state the physical state for the carbon dioxide and silicon respectively. So where the silicon dioxide is actually solid and the carbon dioxide is gas. Okay, so this all must be already in your mind for the structure and also the physical state. Firstly, how we can get 8 marks for the explanation for the structure and physical state. 8 marks. So that means for the carbon dioxide, at least you need to think what is the 4 marks there. And another 4 marks will be the discussion for the silicon dioxide. Okay, if we according to the table here, we only have the structure, 1 mark simple covalent for carbon dioxide, and the physical state, which is gas for the carbon dioxide. So you have to think how we can get another 2 marks here. So that means we have to discuss more about the shape also in this question. Okay, so you can look at the first carbon in the carbon dioxide is sp hybridized and is linear in shape with bond angle of 180 degrees. So be like this lah. So carbon dioxide is a simple covalent molecule. One carbon will be bonded to 2 oxygen atoms by double covalent bond, but molecules are held by the weak van der Waals forces. So that's why the physical state for the carbon dioxide is in the gas. So therefore, exists as gas under room temperature. Okay, so that means 2 marks will be for the structure and bonding discussion, and another 2 marks will be why the carbon dioxide exists in the gas. So we have to discuss that because it has a low boiling point. Okay, so why it has a low boiling point? Because it is actually simple covalent molecule. The intermolecule forces between the carbon dioxide molecule is held by the weak van der Waals. Okay, as I already mentioned in our last discussion, when we discuss about the bonding, we have to discuss about the structure. If there are simple covalent molecule, there will have the intermolecular forces, which is the van der Waals. But when we come to discussion about the thermal stability, we will discuss about the bond between the C and O here. Okay, but here, gas is also in carbon dioxide. So that means the force held by the carbon dioxide molecule is van der Waals. Well, why you can see the silicon dioxide is insolid? Because it is a giant covalent structure. When giant covalent structure, all the bond silicon to oxygen will play an important role in the form of the solid already. So there is no any van der Waals forces in the giant covalent structure. Understand? So this is a main thing you have to understand how to discuss. For the silicon dioxide is sp3 hybridized, and each silicon is covalently bonded to 4 other oxygen atoms by single covalent bonds. So silicon dioxide has tetrahedral arrangement. So we have to discuss the shape, as I mentioned. Okay, so silicon dioxide has a giant covalent structure, so with strong covalent bond between Si and O atoms. So you see, when we discuss about the physical state where the silicon dioxide is in solid, we not discuss any intermolecular forces already, because there is not exist in the giant covalent structure. They are actually bonded with the strong covalent bond. You can see this is a structure for the silicon dioxide. But if for the carbon dioxide, they are actually, if you discuss the thermal stability, you still discuss about C and O. But when we discuss about the form in the physical state, since it is a gas in room temperature, that means they will be held by the intermolecular forces here, which is a weak van der Waals. But here, all the SiO2 will be held in the covalent bond. So we discuss silicon and oxygen here. Here the answer accepted will be already stated. Okay, total here we have about 9 reference scheme here. Okay, so we compare to Laporan Peperiksaan. Okay, so you can see many candidates were able to explain differences between carbon dioxide and silicon dioxide in terms of physical properties, but they fail to relate. Okay, the first they already know carbon dioxide is in gas form, while the silicon dioxide is in the solid form, but they fail to relate the structure. So the structure for carbon dioxide is in simple covalent molecule. So when we discuss this, we have to discuss together with the van der Waals forces for the carbon dioxide. And for the silicon dioxide will be in giant covalent structure, as already explained just now, is held by the covalent bond. So these two is related. And the student also not mention the shape for the respective carbon dioxide and silicon dioxide here. Okay, so here already add on the answer here, you have to give the shape if we based on the discussion and comparison between the scheme to the Laporan Peperiksaan 2019. So that means in the future, in your exam, so you can discuss about the shape of the carbon dioxide and silicon dioxide when the question asks you to discuss about the structure. So the structure must be right also together with the shape. So we are looking what is actually NPM needed through the Laporan Peperiksaan. Okay, so the scheme is just a reference for us. We can just add on any advisable answer according to the Laporan Peperiksaan. Understand? So we have to add on shape, which is normally we not think to write if we want to discuss about their structure, right? Okay, so the next question will be the question 13. Okay, so this is the question in 2019 repeat. So when for repeat question, so we don't have any Laporan Peperiksaan to refer but we have already seen and go through so many Laporan Peperiksaan since the 2012 to 2019. We can use the advisable answer given in the Laporan Peperiksaan already, right? And we try to meet what is the NPM required, okay, in your answer. Okay, so let us read the question. MCl4 is least thermally stable chloride in group 14. Okay, so MCl4 is also easily hydrolyzed. Identify the chloride and explain its thermal stability. So again, you see, it's already discussed the quite similar question in 2012 section B and 2016 repeat section C. So here the main point here will be least thermally stable. Okay, and second is easily hydrolyzed. So we have to bracket what is the keyword in the question, and then the question asking you for the identification for chloride, explain its thermal stability. So in first 5 mark here, actually we can already know what is the MCl4 here. Since the least thermal stability will be the lead tetrachloride. So the first division here is about the thermal stability of the tetrachloride here. Okay, so based on the table, okay, we already discussed for many times using the same table, same info here. Okay, so here we already know from the table, the carbon tetrachloride, silicon tetrachloride, and germanium is stable. The unstable one will be tin tetrachloride and lead tetrachloride, but the question one, the least one, so for sure will be the lead tetrachloride. So the tetrachloride of the lead will be decomposed on slight warming to form lead-2 chloride and release the chlorine gases here. Okay, so this is what we already know and in our mind. So the first mark will be, you have to write identification for the chloride here. So the first mark will be the lead tetrachloride. Another 4 marks here, you have to discuss the stability of lead tetrachloride here. Okay, you have to explain another 4 points here. Okay, so here you can see we have to discuss the SCl bond. So that means we have to discuss PB and Cl bond, here. Okay, so the bond will be covalent bond, and here, the according to our revision just now already mentioned, CCl4 until germanium Cl4 will be the stable in high temperature. Okay, so when going down to the group, the bond become weaker. The strength of the bond become weaker because the length of the bond between M and X is become longer. So when going down the group, the length of MCl bond decreases due to the increase in the size of the M atom. So the MCl covalent bond get weaker, hence the thermal stability decreases. This one is regarding our revision. But here, we just need to discuss the lead tetrachloride. We don't need to explain overall. We need to answer as per discussion. First mark will be given for the identification of chloride. Second mark, you have to discuss the thermal stability for lead tetrachloride. Okay, not all the elements in the group of 14. Okay, so the first mark will be given for the identification. Another 4 marks will be the explanation regarding the thermal stability here. So as per our revision, so lead tetrachloride will be decomposed, become lead 2 chloride and release the gas. You can write in the equation or in the sentence. And then we have to discuss why. As per mentioned, the bond between the Pb and Cl is a covalent bond, and this type of covalent bond will be the bond length will be increased when going down to the group as the size of the lead is the biggest. So the length between Pb and Cl will be longer. When the bond longer, so the strength will be decreased. Okay, so it will be stable at the +2 oxidation state, right? Okay, so which is the lead 2 chloride. Okay, why? Because of the inner pack effect also here. So this one maybe we're not discussing, we discuss the covalent bond, right? Okay, so but the scheme here, they also include the discussion regarding the inner pack effect. We can add on any information is relevant. Okay, please write more than 5 points here. Okay, so the next, describe the molecular shape of the MCl4. Okay, so we know all the MCl4 tetrachloride for group 14 will be in tetrahedral shape. So the 2 marks here will be, first mark, I think all will be get, which is the tetrahedral shape. Another one, here another answer here will be given is for the atom M will be sp3 hybridized. So this is a reference answer here, 2 marks. Okay, so and then the third question here, we have to explain why MCl4 is easily hydrolyzed. Okay, when we explain regarding the hydrolyze, so this one actually we already discussed in the past year question 2016 repeat. So here we have to explain only for the lead tetrachloride. As our referring to our revision notes here, so all the tetrachloride except carbon tetrachloride can undergo hydrolysis with the water. So this is also the discussion we already discussed together. Okay, so that means lead tetrachloride is able to undergo hydrolysis. Okay, the reason. Okay, so this is the equation, a general equation for the hydrolysis process. And the mainly discussion here we have to discuss because the lead use their empty d orbital, right? Okay, which is allowed the water ligand to donate their lone pair to form coordinate bond or dative bond, and the mechanism will be like this. So that means we have to discuss about the empty d orbital where allow the water ligand to donate their lone pair, okay, and form the dative bond with water, and then we give the equation. Okay, here 4 marks, you will get the 4 marks here. So that means in the discussion, we just discussed about the lead tetrachloride here. Okay, so you can see the answer is very simple as we already discussed at the previous Stpm question. Okay, so first mark, lead has empty d orbital, can expand its valency to form coordinate bond with water molecule, and then you give the equation. Okay, so B, spodumene is a pyroxene mineral and a source of the lithium. Describe the structure of spodumene and draw its repeating units. So from here, maybe we do know what is the spodumene here, right? But the question actually asks you to describe the repeating unit for pyroxene, because the question already given the info. The spodumene is pyroxene. So again, this is actually we discussed already, which is similar to year 2015 section B. But actually the spodumene here is lithium aluminium silicate lah. Okay, and then the appearance will be like this lah. But let's say you do know, okay, what is the spodumene? Never mind, because we are actually know what is pyroxene already. So this is the revision where we actually already discussed many. Okay, so the pyroxene is one of the type of the chain silicate. Okay, so the structure will be like this. So you have to draw. So we have to discuss actually the single chain silicate. Understand? So the single chain silicate is a common character. Okay, where each unit of the SiO4 4- will be shared two oxygen atoms to form long linear chain. So the repeating unit here will be SiO3 2-. And the physical characteristic, we advise students to memorize all the info here. Although the question here not ask you about the physical character. Okay, but this is a minimum info you have to memorize. So the pyroxene are brittle and break easily because the individual single chain is held by the weak van der Waals forces. And the question here asks you to give example. Okay, no give example, just describe the structure and draw the repeating unit. So the example we learn through the notes will be the sodium silicate, magnesium silicate, calcium magnesium silicate. So here is actually the lithium aluminium silicate. Okay, so the first mark will be given by the for the drawing of the structure. So the question asks you to draw is repeating unit. So the repeating unit here is SiO3 2-. The second, you have to give the common character. Okay, it is a single chain silicate, and each unit of SiO4 4-. Okay, unit will be shared to oxygen atom per silicate. And we discussed the repeating unit here is SiO3 2-. So you'll get 4 marks. So actually it's similar to question 2015 section B. So we memorize the same information, then we apply at the almost same question. Okay, just the question add on the spodumene here. But actually we discuss about the pyroxene. Okay, then the next will be the question 14. This is a question in 2020, repeat. Okay, so group 14 of the periodic table consists of element graphite, carbon, silicon, germanium, tin, and lead. Okay. So you can see the main difference here is the question here asking you the carbon and the electrode will be the graphite. And normally the previous question in the past will be asked about the diamond. So you have to state the electrical conductivity of the group 14 elements. Explain your answer. If I say we take out the graphite, carbon here, the question is actually also same as the 2012, 2013 repeat, 2019 repeat. Okay, but you must be careful here is where the diamond is actually a non-conductor, while for the graphite carbon here is a conductor, right? Okay, because we know that from our same one. Okay, so the graphite has a delocalized electron, and the diamond doesn't have. And this one we actually also discussed in our answer in the question of Stpm 2009. Okay, the question asks us to draw the structure for the carbon and the carbon graphite and the diamond. And we explained also, okay, both of them, they have the same giant covalent structure, and the diamond EC is undergo sp3 hybridization. So that means all the carbon will be bonded covalently to others. Okay, so that means they do not have any extra electron. Okay, so that there is no any delocalized electron here. So we have to relate what we learned already in same one, and also the discussion we already did, okay, in our part 1 of the section C actually. And the video clip I recording and already sent to you all. You can go back and have a look for this discussion. And then for the graphite, okay, each carbon will be undergo sp2 hybridization. So that means there is extra electron present in the graphite carbon. So that means there are presence of the delocalized electron. So when we consider the graphite is a conductor, so this is the main difference you have to discuss in the question here for 2020 repeat here. So others for silicon, germanium, tin, and lead actually the same. So we already discussed so many questions regarding the conductivity. Okay, so here the main difference will be the graphite carbon. So that means here the graphite, the lead, and the tin will be considered as conductor. Okay, so for the graphite, you have to discuss presence of the delocalized. Why? Because of the each carbon in the graphite is undergo sp2 hybridization. So that means they have the extra delocalized electron here. Okay, then while for the tin and lead, this is very simple. We can discuss about the energy gap lah. Okay, where the electron is able to jump from the valence band to the conduction band is the same. Just a different discussion is about the graphite carbon here. Okay, and then the silicon and germanium, you have to discuss about the gap. Energy gap will be small. Okay, and the electron is still able to jump from the valence band to conduction band. There is no any non-metal in our discussion for this 2020 repeat question here. Understand? So we have a look for the answer here. So you can see carbon, tin, and lead are conductor. Okay, so silicon and germanium are semiconductor. Carbon has the localized electron between hexagonal layer due to sp2 hybridized carbon. So just now I already explained. Okay, which you can use the info we recall at our question 2009. Okay, and then the tin and lead are metal that can delocalize the electron from the metal to form C electron. So that means here we can discuss the concept of present and absent of the delocalized. When we see there is a metal, we can discuss the presence of the delocalized electron. And as per our advice through the Laporan Peperiksaan 2012, we can discuss also the energy gap, right? Concept of energy gap. Here, the silicon and germanium will have a small band gap, small energy gap. Okay, so it is considered as a semiconductor. Okay, so actually can add on the tin and lead. Okay, so the gap, there is no gap for the valence band and conduction band. Okay, for tin and lead, right? So we can write two of the concept in the question, because the question here no ask you to specify to write the concept of the energy gap. So that means both is accepted, or maybe the mark will be given for different concept here. So I advise write both in the exam. Okay, so the next will be based on the graph of melting point against the group 14 elements below. Explain the trend of the melting point. You see, this question we already discussed, very similar to the year of 2015 in the repeat also. Here the revision we already go through together. Okay, in our part 2. Okay, in our part 2. So the revision here, you can look at the table. Okay, so carbon have the highest melting point, and the lowest will be the tin. Okay, so we have to discuss why. Suppose the lead have the smallest, have the lowest melting point, but here is different. Okay, so we have to discuss the overall. Okay, overall, since the question is asked the trend of the carbon 14. So firstly, you can see the silicon, germanium, carbon that has a higher melting point compared to the tin and lead. Okay, because the structure is different. Okay, for silicon, carbon and germanium, they are in the giant covalent structure, and the tin and the lead will be in giant metallic structure here. Okay, so you can see, I already explained. Okay, and then the group trend to further emphasize the increase of the metallic character down the group. So here you have to explain because the character is changed from the covalent to the metallic. Okay, so this is due to the intermolecular force decreasing down the group resulting in the change from strong covalent bond to metallic bond. So this is a revision we do here lah. Okay, and then we see what is the point we can be used in our answer. Okay, so here again you can see the table. Okay, I already separate. Okay, when we discuss about the giant covalent structure, we discuss the size of the atom. When the size of the atom increase, the length of the M to M will be increased. So that means here carbon to carbon bond will be the shortest compared to the germanium to germanium here lah. So that means the strength for the shorter bond will be higher. So that means C to C will be higher compared to germanium to germanium lah. So the strength of the covalent bond decreases. So the melting point decreases from the carbon to the germanium. So and then we have to discuss another two, which is the tin and the lead. Okay, so tin and the lead, you see that the lead have a higher melting point, which is unexpected, right? We expect when the size going bigger, so the melting point will be lower, but here it's not. Why? Because the structure is different. Okay, so you can see the lead is more close compact, which is known as the face center cubic structure. So cause the melting points higher than the tin. So the tin, the structure will be tetragonal structure. So we have to explain both lah. Okay, so the metallic bond for lead is stronger than tin. So this is the key. We discuss all. We have to discuss for the giant covalent structure, where we discuss the size, we discuss the length bond, we discuss the strength covalent bond, and we discuss about the tin and the lead. We discuss about the metallic structure and why the lead have an unexpected higher melting point, where it is actually bigger compared to tin because of the structure of the face center cubic make it more close together, and the melting point for the lead will be higher. So let us go through what is the answer we have to write here. So the first, we have to explain the trend. So the first mark we explain, generally the melting point for the group 14 is decreases. Okay, so this is when we discuss general, we have to discuss overall. Okay, and then we discuss the giant covalent structure here, where there are carbon, silicon, and germanium. Where the germanium have the biggest radiance, okay, so the bond length will be longer, so the bond strength will be weaker, right? And then we discuss about the tin and the lead, where they have the strong metallic bond. Okay, and then the lead has unexpected higher melting point due to it has a more closer compact structure we know as the face center cubic. So this is what we can relate what we learn and the way we answer. Okay, and the next will be the B, explain the role of the lead 4 oxide in the equation below. Okay, so here when we discuss the role, we discuss about the reducing agent or oxidation agent. So here you can see the lead 4 oxide, okay, where it has the +4 oxidation state, okay, change to the lead 2 chloride here. So where it has the +2 oxidation, so that means the reduction occur here, okay, for the Pb4 plus lah, okay, and we can see the HCl here, the chlorine is from -1 and then oxidized to chlorine gas. Okay, so this is what we can think here. Okay, it's quite similar to another 2 question we already explained, but here the more difficulty here is the question not ask you or not mention any oxidation or the reduction words. Okay, here. So actually the keywords here is the role. So the role representing, you have to discuss about the reduction and oxidation in the question. The question actually asks you regarding the type of agent. So when we discuss about the agent for the lead 4 oxide, we have to discuss the process where we know as a redox reaction. So actually this is the third example, is we already discussed from year of 2005 to 2021 here already. Okay, so the answer is actually straightforward here. So PbO2 act as the oxidation agents. Seeing the Pb4+ is reduced to Pb2+. Okay, so you have to mention the oxidation state decrease from +4 to +2, and the Cl oxidized from -1 to 0 here. So 3 marks. Understand? So it's a quite similar question we discussed, right? You can go back and look at what I already record if you think you are needed. Okay, so for the last question in our discussion here would be the section C, question 15. Tetrachloride of group 14 of periodic table are liquid at room temperature. When we see liquid, this relate to the bond. Why? Because liquid showing that there has a low melting point. When there is a low melting point, so we show that the group tetrachloride we want to discuss here will be the simple molecule. So when simple molecule, if the question asks about the melting point, we discuss about the van der Waals forces. Okay, this is only for simple molecule structure. Okay, so if we discuss about the covalent structure, the melting point we not discuss the van der Waals because it's not exist in the giant covalent structure. Okay, so we compare the reaction between each tetrachloride with water. You see, when we discuss the reaction with water, we discuss about the hydrolysis. We have already go through so many revisions regarding the process of hydrolysis with the tetrachloride group already. So again, you see it's similar to 2016 repeat and 2019 repeat, section C. Okay, and the revision, you see again, we look at the hydrolysis. So we already discussed so many times. So you must already know that the carbon tetrachloride is not able to undergo hydrolysis because of the absence of the orbital D. For hydrolysis with water, the group 14 elements must consist of the orbital D. So again, you see the same revision will be here. You have to give the equation in your discussion answer, 5 marks here. Okay, we discuss again, the carbon tetrachloride do not have empty orbital D, right? Then for the others, silicon, germanium, tin, and lead tetrachloride, they have the empty D orbital. Okay, but if you compare to years of 2016 or year of 2019, they discuss why carbon tetrachloride cannot undergo hydrolysis. Another year, the question asks why silicon until the lead tetrachloride, the concept there to ask you why 4 of these can undergo hydrolysis because presence of the orbital D. Then the question for 2021 asks both. Okay, you can go through again the past question for 2016 repeat and 2019 repeat. So if you can manage to read all, okay, read all and do all the discussion, you must able to do. Okay, I'm very sure. Okay, especially we already compare many answer scheme together with Laporan Peperiksaan. Okay, so we also already know what is the mistake made by the previous candidate. Okay, and what is the advisable answer you have to state in your actual exam. Okay, so here again, all the information we already learned. So we have to need the element in group 14 have to presence of the d orbital so that the water ligand can donate their lone pair and form the active bond with water. Okay, so this is all the point you can write in your answer. You see here, silicon, germanium, tin, and lead tetrachloride undergo hydrolysis of water, and then give the equation. Okay, so here I advise you add one more M, where is silicon, germanium, tin, and lead okay, for this equation. Okay, so why? Because 4 of the elements here have empty d orbital to coordinate water molecule. Another 2 marks will be for the carbon tetrachloride. It cannot undergo hydrolysis in water because the presence of the empty d orbital. So this is 5 marks here. Distribution 3 marks regarding the discussion for the silicon until that tetrachloride where they are able to undergo hydrolysis. And another 2 marks discussion about the carbon tetrachloride where it cannot undergo hydrolysis in water because the absence of the empty d orbital. So if I say you just discuss one of that, you might not get full marks for this question. So try to avoid the mistake, okay? And what the actually asking you in the question, you have to meet the requirement. Okay, you discuss 10 sentences about the silicon until lead tetrachloride. The maximum mark is only 3. If let's say you not discuss any point regarding the carbon tetrachloride. Okay, so now the last will be explain the trend of the thermal stability of the tetrachloride. Okay, as I already mentioned to you, if we explain the thermal stability, we discuss about the MCl bond. For the tetrachloride group 14, they are actually the simple molecule structure. When we discuss the melting point, we discuss the van der Waals forces. But here we discuss the thermal stability, we will discuss the MCl bond here. So that means we discuss the size. When the size of the group going down is increased. Okay, so that means the bond length between N and Cl will be longer. The strength of the bond between N and Cl decreases. Okay, so the thermal stability for overall, you see, they want to discuss the strength, will be decreased, right? When go to discussion for melting point, the strength for the tetrachloride will be increased because the van der Waals forces increase when the size of the electron increase. So this is the difference when we discuss the melting point and thermal stability for the compound or element where they are bonded with the simple molecule structure. Okay, so again, you see so many years is similar. 2012, 2016 repeat, 2019 repeat. So again, we use the same info. Okay, we discussed already, but here we have to discuss overall. Okay, so again, you see the info as I mentioned just now. The CCl4 to germanium Cl4, they are all stable because of the size is smaller and the length of the bond between M and Cl will be shorter, the strength will be higher. So we require more heats to break the bond here. Okay, so the overall, the bond increase because the size increase and the bond strength will be decreased, hence the thermal stability decrease. So this is a discussion about this section now. So we have to explain the trend, not compare, not just mention one of the element. So the reference answer here, you must discuss the overall thermal stability of MCl4 decrease down group 14. Okay, and then CCl4, SiCl4 and the germanium tetrachloride are thermally stable and do not compose when heated. Okay, and then the tin and the lead tetrachloride decompose when heated. Okay, and release the chlorine gas. So why? Because the size increase, cause the length between the bond increase, hence decrease the strength. So the heat required to break the bond M to Cl will be decreased. Okay, the last B, sheet silicate are known as the pyrosilicate. Draw and describe the structure of the sheet silicate. Give one example. Again, you see here. Okay, we just need to memorize what is the structure for the silicate sheet here. So this is the thing you have to memorize. So the structure will be like this. The common character for the sheet structure is formed when each SiO4 4- sharing 3 oxygen atoms in an infinite 2-dimension arrangement. And then we have to memorize the repeating unit here. Okay, Si2O5 N to N here, you have to memorize. Okay, you have to memorize their physical character. Sheet silicates soft and slippery because they are bonded with the weak van der Waals. Okay, and then we have memorized the example. Okay, so this is a past year question in 2017 repeat, section B, and 2015 section C we have already discussed. Although the question not ask you all about this, but what we already need to memorize all of this at least so that we can answer in actual STPM, right? Because the previous question we discussed, we know already. Randomly, they will ask these 4 things in the question, but here we have to draw. First, draw, describe the structure. So the structure here will be, the silicate here will be share three oxygen now, sharing 3 oxygen atom here in the infinite 2-dimensional arrangement. Okay, 2 marks here, see? And then we have to give the repeating unit, which is the SI 2052 minus here. Okay, and then the question asks you to give the example. You see, you have to give one of the example. So you memorize all the info here, you can score. Okay, so that's all for my sharing in the past year question regarding the chapter 5.